Hello, everyone. It is the Prophet Michael David, aka Aries. I hope everyone is having a wonderful day. Okay, first things first, as I've addressed in a previous video, I'm learning to either quickly address the thumbnail of the YouTube video or tease it. On this one, I'm obviously going to tease it. You can screenshot it and zoom in, but the longer you watch this video and the more you hear me talk, the more you'll be able to figure it out. And then I'll just explain at the end as well. Also, on a side note, as it is a weekday, a working day, I should be wearing my red and black, or at least solid black. But I'm wearing my Triforce t-shirt because it is a geometry teaching day and I can use the shirt as a teaching tool. Okay, for starters, for all my watchers who are not mathy people, what is the twin prime conjecture? Well, in a nutshell, it is this. Is this problem unsolved up to this point in time? Yes. Why? Well, to put it simply, it's because all modern mathematicians just totally use and abuse transcendental mathematics to whatever they want to do with it. An example of how ridiculous transcendental mathematics is. I once saw this video by Mathologer, I think, that was using techniques developed by Bernard Riemann, the same one from the Riemann hypothesis, where he took an infinite set, split it up into two infinite sets, and then basically showed how infinity minus infinity could equal pi, or any other number that you wanted it to equal. And if you can make infinity minus infinity into whatever you want with your type of math, then you can use it to prove or disprove anything, which pretty much makes it worthless. Which why, as a geometer, I deal with shapes, symbols sometimes too, but mostly shapes, and algebra. And as always, as I've stated in a previous video, I'm trying to make this as simple and easy to understand for normal people, not mathematicians. I could care less about mathematicians at this point, which is why I'm always bound by the quote by David Hilbert, which I showed a couple videos ago, but I will show you again. So how did I solve the twin prime conjecture in layman's terms? Well, I didn't study the actual primes because again, remember, the primes are only magnitudes. They're only line segments. They convey very little information. I looked at the squares of the primes because the squares of the primes are squares. They're by definition area, and that's how we perceive all our information in the universe. It's like my shirt. Lines are only, in reality, the infinitely thin boundary conditions between two separate things. In this case, colors on a t shirt. But that's what lines truly are. They're infinitely thin. So, how are primes normally these days portrayed to you, and why are they so confusing? Because most of the time they are showed in a format like this. It looks almost completely random and it's almost worthless. It's really hard to understand. How they can be shown in a much better way is like this. All right, so what I did was I kept the base 10 numbers because that's what everyone recognizes. But what I did was I put them in a base 6 format, hence the 1 mod 6, 2 mod 6, 3 mod 6, 4 mod 6, 5 mod 6, 6 mod 6. All those being 1 plus 6, plus 6, plus 6, or 2 plus 6. As you can see in this format, all of the primes fall on either the 5 mod 6 or the 1 mod 6 lines. And I just did the different colors because I always make 5 mod 6 primes blue and 1 mod 6 primes also same thing, 7 mod 6 primes green. So go ahead, stare at it for a while, but you can see they all line up on two separate lines only. Okay, this next slide is the exact same thing, but I also incorporated two more colors for prime squares and then composite numbers, which are composites of two separate primes. So that being said, blue is 5 mod 6 primes green is 1 mod 6 or 7 mod 6 primes, pink is prime squares, and orange is prime composites, composites of two primes. Just a side note as you look at that last screenshot, as you can see, all of the pink numbers, the prime squares, are on the 1 mod 7 line or the 7 mod 7. I will use the terminology for a while, but just remember it's the same thing. Just a lot of the time we'll start with the primes squares of 5 and 7, so 25 and 49, because 7 mod 6 is the same as 1 mod 6. 7 minus 6 is 1. In the 5 mod 6 line, 5 minus 6 is negative 1. So in a way, the 1 mod 6 line spawns from 1, and the 5 mod 6 line spawns from negative 1. To some people, this may seem like it proves the twin prime conjecture right there, but it doesn't. You're still dealing with magnitudes, and to really gain an appreciation of the prime numbers and see the true structure that they have that solves the twin prime conjecture, you still have to deal with areas. And so I had to find some way to modify the primes into areas. So I discovered or created or developed the following equation that I call x numbers that were modified prime squares. Now, if you use that equation, you can modify your base 6 spreadsheet and it'll look like this. As you can see, after modifying the primes to x numbers, all x numbers that are made from primes have to end in either 8 or 0 from 7 onward. And all my x numbers that relate to primes have to end in either 8 or 0 for the same reason that prime squares have to end in 9 or 1 after 7. Look it up if you want to. In full disclosure for that last slide, I took out the 1 because the z number of 1 is 0. So that first 4 and 8, that's 5 and then 7 below it. And I did that again because the number line and with the rules of the primes really doesn't start until 7 because 5 doesn't end in a 1 or 9. And now some of you might be saying, well, that kind of solves the twin prime conjecture, but not really. I'm still dealing with magnitudes. I'm just taking numbers and adding 6 and making a table out of them, but I'm not actually showing that the prime squares or modified prime squares, aka x numbers, show the same twin prime spacing as if you put the 5 mod 6 right next to the 7 mod 6 line. In other words, I needed to find some sort of mathematical construct that was based on purely area that I could find the square primes or my z numbers and that they showed the same structure as the 5 mod 6 line and 7 mod 6 lines. And eventually I did in the weirdest place. Yes, those are the times tables. And as you can see, the 5 mod 6 primes are in blue and the 7 mod 6 primes are in green, and they form lines on the times table. And the purple numbers are just prime squares, unmodified in any way. And this pattern continues on to infinity. Here's a screenshot of the end of my spreadsheet. And that does solve the twin prime conjecture because now we're dealing with the time tables, which is a total area thing. All of the numbers on time tables are areas, and all of the 5 mod 6 z numbers and 7 mod 6 z numbers follow this pattern, and the important one is the one squared on the bottom. In other words, the most efficient way to find all the primes isn't to try to find them all on the single number line. It's to split them up like this and then use the proper equations to find out which primes to check, and then you can just ignore all the other numbers in the universe. And that equation is 6n squared. In other words, that's the line that runs between the 5 mod 6 and the 7 mod 6 lines. So as you can see on the graph, 6n squared, if you put 1 in for n, that's 1 squared times 6, that's 6. N squared, 2n squared is 4, times 6 is 24, then 54. You can see that's always the number that's going to be in between the two primes if there's one over the top and over the bottom. Which means the equation for the 5 mod 6 prime, or possible prime, the one on the top of that number, is going to be 6n squared minus 2n, and the prime on the bottom, the green one, possible prime, is going to be 6n squared plus 2n. So you have to check the first two sets, but that's fine because they're prime anyway. But the pattern really doesn't start till n equals 3, and n equals 3 for 6n squared is 54. So starting with n equals 3, all you have to do to collect all the primes is check up and down, check up and down, check down, check up and down, and then repeat forever, and you'll get all the primes. So then finally the thumbnail. What I finally did was, since all the numbers on the timetables were X numbers, or they're there and everything, I modified them back into primes, and then I marked them all the colors that I showed you earlier. Blue for 5 mod 6 primes, green for 7 mod 6 primes, pink for prime squares, and orange for composites. All right, I'm going to sign off now. As always, everyone have a good day, and remember, do not hurt each other and try not to lie. I will talk to you in a few days.